What's happening, guys? My name's Nicholas Renaud, and in this video we're going to be going through advanced hand pose tracking. So first up, what we'll do is we'll be able to detect our left hand versus our right hand, and then we'll also go through some kinematics. So we'll actually be able to calculate the angles within our hand. And we'll actually do this for multiple joints as well. So we'll actually loop through and be able to calculate multiple joint angles. Let's take a deeper look as to what we'll be going through. So in this video, we're going to be going through advanced hand pose tracking. Now, in order to do that, we're going to be leveraging the code that we wrote in part 1 of the hand pose tutorial, and I'll include a link to that in the description below. So what we'll do is we'll pick up where we left off and we'll detect our left hand versus our right hand, and this is actually pre-built inside of the MediaPipe library. So we won't need to do too much, it's just really pre-processing our results. Then what we're going to do is we're going to write a function to be able to calculate the angles within our hand. So specifically, if I curl my finger like this, we'll be able to get the joint that is actually represented here. And we'll also represent those in real time. So we'll actually render the angles to the screen. Now, the cool thing about this is that you can actually repurpose this particular line of code and actually calculate a bunch of different angles. So there's a function, or the function that we'll write will actually be able to handle multiple sets of joints. Let's take a deeper look as to how this is all going to fit together. So first up, what we're going to be doing is leveraging our hand pose code from part 1 of this tutorial, and I'll show you where to get that code. Then what we're going to do is leverage the MediaPipe results that we've got to be able to detect our left hand versus our right hand. And then last but not least, we'll calculate the angles between the different joints in our hand, and again, render those to the screen using NumPy. Ready to do it? Let's get to it. Alrighty guys, so in order to go through advanced hand pose tracking tutorial, there's really going to be two things that we're going to do. Now, the reason that there's only two is that we're going to be building off part 1 of this tutorial. Now, if you haven't seen part 1 of this tutorial, by all means, do check the link in the description below. You'll be able to get access to that tutorial, but I'll also include a link to the code that we're going to be using to kick off from. Now, in this case, what we're going to be doing is we're going to be going on down, and we are going to be doing 2 additional things to our baseline code. So we're going to be detecting our left and our right hand, and we're actually going to render those results to the screen. And we're also going to be calculating the different angles within our hand. So this is going to allow us to calculate any 3 angles or use any 3 points to be able to detect those angles. Now, this code that I'm working with here is the code from part 1 of this tutorial. Now that code is available at github.com/knickknocknack/MediaPipe handpose. So in that particular block of code, we did a couple of key things. So specifically, we installed and imported our dependencies. Then what we did is we drew all the different landmarks within our hand using a real-time feed from our webcam. And then the third thing that we did is we actually output our images as well. So from the results and from the detections that we got from our webcam, we were able to write out those images to a folder within our desktop. In this case, we're not going to want to write out those images because we're really focused on those 2 additional components that we're going to be adding. Now let's take a look at what we did in that first tutorial. So again, we imported our dependencies. So if I run that and we set up MediaPipe, so if we run that, and then if we run this big block of code here, this is effectively going to give us our hand pose model. So this should ideally bring up a little Python pop-up, and you should see the results there. Okay, so we've got our Python pop-up, so you can see that it's a real-time feed from my webcam. Now, if I bring up my hand, you can see that we get all the different landmarks from our particular model. So that's all well and good. Now, what we want to do is really extend this. So we want to be able to detect that this is the left hand and that this is the right hand. Now, a thing to call out before you do go through this tutorial is that the detections aren't always hyper accurate for the left and the right hand. So I'll show you how to do it, but again, keep that in mind. And these results are actually coming from the native MediaPipe model. Now, you could build up on top of this and build a classification model to improve on that accuracy, but I figured I'd show you this method to begin with. By all means, if you do want to see a different tutorial on how to do it slightly differently, let me know in the comments below. Now, enough playing around. Let's close this down and actually start building up our, what are we going to do? Left and right hand mark detection. Now, the cool thing about MediaPipe is that it actually does have native left hand and right hand detection. So if we type in results, this is actually coming from our results variable that we get from our MediaPipe hand pose model, which is this here. Now, we should get some results, but I don't know if I put my hands down. So it looks like results dot, and if we type in multi-handed landmarks, Okay, so we don't have any results. Now, the reason that we don't have any results is that we put our hand out of the frame. So this results variable is going to be the result from the last frame that MediaPipe had a chance to actually go and detect. So if we go and run this big block of code again, let's let it pop up. I'm just going to keep my hand in the frame. So if you get a little gray pop up and then it closes when you do run this, just run the cell again and you should get your result. Cool. All right, so that's my hand. That's all well and good. I'm going to keep it in the frame the entire time. And this effectively means that for our results variable, it's going to represent the last particular frame that it's actually gone ahead and detected. So if I hit Q now and scroll on down to results, again, we've still got a results variable. And if I type in dot multi-hand landmarks, you can see that we've now got all of our different landmarks, right? So all of these represent different landmarks. Now, if we actually wanted to, right? So we can actually, let's just take a look at how many results we've actually got. So it looks like we've only got a single result back. But if you get multiple hands, normally you'll get multiple results. In this case, we've only got one, so we've got that. Now, the cool thing about this is that you can actually go and extract the specific landmarks for a specific joint. So if we take a look at this particular landmark map, right? So we know that joint 0 is going to be our wrist. Now, if we type in mp underscore hands dot hand landmarks or hand landmark dot wrist, let's just take a look at that. So this should be dot landmark. So this is actually going to allow us to actually extract a landmark for any particular joint that we've got within that particular detection. So in this case, what I've written is results.multi-hand landmarks, and then we're grabbing the first result, which is for our first hand dot landmark, and then we're passing through the map for our wrist. So this variable here is really just going to be variable 0. So if I bring that up, so this is just giving our result of 0. Now, if we wanted to grab a different landmark, so say, for example, we wanted to grab the pinky tip, right? So if we just change that variable, so dot pinky tip, that's going to give us the coordinates for our pinky. Now, the reason that I'm showing you this is because when we go and render our left or our right hand text, we're actually going to render it on the wrist component. So you'll actually be able to see left and right rendered right here or printed out here using some text. Now, the nice thing about the results that we get from the hand model is that we also get whether or not it's a right hand or left hand. So if I type in results dot multi-handedness, this is going to give us which hand is actually being detected. Now, in this case, I actually had my left hand left, so you can see it's gone and printed out the label left, which is all well and good. So what we now want to do is write a function which allows us to map through the multi-handedness, which is this over here, to the actual hand that we've got detected. Now, the reason that we're doing this is because the index that we get back from the results.multi-handedness array is not always in order. So ideally, we want to make sure that we get the right coordinates with the right classification. So let's go on ahead and write this function. So it is a fair bit of code, but again, we're going to go write it out, go through it, and then we'll actually apply it. So let's go on ahead and write this out. Okay, so we've written 4 lines of code there. So we'll pause there and let me explain what we've got so far. So what we're doing is we're creating a function called getLabel. And again, this is going to return the text that we actually want to render for that particular hand, as well as the coordinates for where we're going to render it. So we're actually going to get 2 variables out of the result of this function. We haven't written that yet, but we're going to get to it. So our function's called get_label, and then to that we're passing through 3 different variables. So we're passing through the index, and this is effectively going to be the number of the detection that we're working with. So remember, if we detect multiple hands, out of this results.multi-hand landmarks variable, we're going to get multiple landmarks or multiple sets of landmarks. So in this case, you can see that when I go and grab point 0 or index 0, that's for our left hand. But if we had a right hand in there as well, we'd have a second result inside of that as well. Now, in this case, we're first up going to pass through the index that we want, and that is whether or not we're passing through the 0th detection or the first detection or the second detection, so on and so forth. Then we're actually passing through our hand landmark. So this hand variable is going to represent our landmarks or hand argument. And then the third thing that we're passing through is our results. So the complete results variable. So that is going to include both the multi-handedness results as well as the landmarks for both of our hands or multiple hands. Then what we're doing is we're creating a new variable, which is called output. So output is going to be the final variable that we actually go and push out as a result of this function. And we're initially setting it equal to none. Then what we're doing is we're looping through all of the results that we get inside of our multi-handedness variable. And in this case, we've just got one result, so we're going to be looping through once. So to do that, we've written for IDX, which represents our index, comma, classification, in enumerate, and then to that we've passed through results dot multi-handedness. So effectively, we're going to be looping through this over here. Then what we're doing is we're actually going into the classification. So imagine we've got this over here. So it's effectively going and grabbing the first variable and grabbing that dot classification, and then we're grabbing the first variable there, and then we're grabbing the index. So it's checking if this index matches the index for our hand. So in this case, remember we detected one hand and our index is index 0. So in that case, it'll be true. So it's effectively doing this check. It should be num. So inside of our big function over here, the index for the detection is represented as a variable called num. So effectively, we're going to be doing this. So in this case, it's going to be true. Then we're going to go on ahead, grab our text, grab our score, and then grab our coordinate, and then push that out as a result of our function. So let's go on ahead and finish this off, and then we'll actually go on ahead and apply it. Okay, so that is our function now done. So what I went and did is I wrote 1, 2, 3, 4, 5, 6 lines of additional code. Now let's go through and explain what we've actually written here. So the first block of code is actually processing our results and grabbing our label and our score out of our multi-handedness variable. So again, let's take a look at that. So results, multi-handedness. So it's effectively going to be grabbing this variable and this variable over here. Now to do that, we've written label equals classification.classification 0. So this is grabbing our first variable. So if we grab that and grab .classification, got that. So it's effectively doing that and then grabbing .index and then grabbing .score. And it's storing those in variables called label and score. Then what we're doing is we're doing a little bit of text formatting. So we're going to take our label and our score and we're going to convert them into one big string. So to do that, we've written text equals quotes and then a set of curly braces space, another set of curly braces, and then another quote, dot format, and then to format, we'll pass through two key arguments. So we've passed through the label, which is this over here. And then we've gone and rounded our score because by default, we're going to get a score which has a number of decimal places. So if we actually round that by using round and then comma 2, this is going to give us a single value, which is a little bit slightly more formatted. So to do that over here, you can see that we've used round, pass through our score, and then pass through comma 2. And then the next thing that we've done is we've gone and extracted the coordinates that we actually want to render this at. Now remember up here, I was sort of showing you how to actually grab the wrist coordinate. This is exactly what we're doing over here. So we're grabbing our hand result, grabbing the landmark, and then we're passing through that we want our wrist coordinate. So to do that, this should actually be MP underscore hands, typo there. So MP underscore hands dot hand landmark dot wrist, and then we're grabbing the X coordinate, and then we're doing the same thing, hand dot landmark. And then to that, we're passing through the index, so MP underscore hands dot hand landmark dot wrist, and then we're grabbing the Y coordinate, and we're storing that inside of a NumPy array. Then what we're doing is we're multiplying it by 640, 480. So these are the dimensions of our particular webcam, but you can extract your own or change this if you need to. So np.multiply, we're multiplying by that. And if you've seen the MediaPipe holistic tutorial where I do whole of body tracking, this line of code is going to be really familiar, because effectively what we're doing is we're grabbing the coordinates from the hand pose model and then multiplying it by the dimensions of our webcam to be able to get the appropriate dimensions to print out our results to the screen. So once we've got our coordinates, we should get back a coordinate array, which is two values, our x and our y variable. We're then going to append those into an output variable. So output equals text, comma, coords. And then we're returning our output. So ideally what we should get out of this is a string, which looks like this. So ideally will be our label and our score plus our coordinates. Let's go on ahead and test this out. So if we run this, looks like we've got an error there. This should be equals index. And then if we run get label, so get label, pass through num, which is the detection that we're actually looping through up here. So that's up there. So again, if you want a deeper walkthrough as to how we actually set up that looping, by all means do check out part 1 of this tutorial. So we're going to pass through num to that hand and then results. And ideally, we're getting back our results array. Now, it looks like we've got a little bit, oh, okay, this is the wrong way around. So what we should be getting out of here is, I believe it's, let's just double check that. Is a label? Yes, label. Cool, that's better. So you can see out of this function, what we're getting back is the hand that we've actually detected, the score, and then we're getting the coordinates that we want to render it at. Now, what we actually need to do is apply this function to our big block of text. So let's go on ahead and copy this and paste it here. Now, what we're going to do is we're going to pass through this getLabels function, this over here, just under where we're rendering our results. Now, what we need to do is we're going to first up get the coordinates. So we're going to get the label and the coordinates, and then we're actually going to use the cv2.putText method to actually apply that to our image. So let's go on ahead and do this, and then we'll see our results. Okay, I think that is all well and good. So we've written 3 new lines of code there inside of our big block of text. And really, these 3 lines of code are going to allow us to render a left or a right hand detection. So to do that, first up, we're checking if we've actually got any results. So remember, we initially set our output to none. So if we don't actually have a result or a mapped result, we're just going to get nothing back. So first up, we check if we do have something back. So if get underscore label, and then we'll pass through our different arguments. So num, comma, hand, comma, results. So this is going to be the number of our detection, the actual hand landmarks, which is the same as that, and then our full results variable from over here. And so assuming we do get some results back, then we actually go and run our getLabel function again. But this time we're actually unpacking our variables that we're getting back from our getLabel function. So we're going to get back text, comma, coord, and then to actually extract those, we're using the equal sign, and then we're running the function. So get underscore label, passing through num, passing through hand, passing through results again. And then assuming we've successfully got our text and our coordinates, what we're then going ahead and doing is we're using the cv2.putText method to actually render that to our image. Now to that, we've passed through a bunch of different arguments. So the first one is image, second one is text. So first up, we're actually passing through the image that we're working with. Then we're passing through the text, and this is going to be left, and then the number 1.0. So that's our rounded score. Then we're passing through our coordinates that we get back. We saw that a little bit earlier. And then we're passing through some standard CV2 requirements. So passing through the font size, font color, the line width for our particular detection, as well, or for our particular block of text, as well as the line type. So to do that, we've written cv2.font underscore Hershey underscore simplex, font size of 1, pass through our color variable, which is in the format of BGR. In this case, we've set it to 255, 255, 255, which will be white. And then we'll set our line size to 2 and then set our line type to cv2.line_AA. So all things holding equal, we should now be able to get our left hand and our right hand detected. So let's go on ahead and run this. So I've just hit Shift Enter. So ideally, we should get this running. Cool. So we've got our face detected. Now, if I go and put my hand up, you can see that we've got our left hand. So if I bring up my other hand, it doesn't look like I've got anything detected there. Both hands got left and our right hand detected. Pretty cool, right? So this sort of takes it one step further. Now, in this case, we're getting pretty accurate detections, but sometimes what you'll actually notice is that it mixes up the left hand and the right hand. In this case, we're all well and good. If you do get less than better detections, there is another way that you can actually go on ahead and do this. So you can actually perform some custom classification. But in this case, we're looking pretty good. So we've got left and our right hand detected. So our left is rendering with a score of 100% and our right is rendering with a score of 100% as well. So you can see that there. We can bring down the green screen and test that out again. Right, so again, we're getting our left hand, we're getting our right hand, we're looking good. And if we turn our hand a bit, you can see that our right hand score is changing, our left hand staying pretty strong. Cool, so that's the first part done. So we've now gone and detected our left hand and our right hand. Now, the next thing that we actually want to do is actually go on about and calculate our different angles. Now, again, if you watch the MediaPipe holistic tutorial, you would have seen how we actually went about calculating those angles. This time, what we're going to do is calculate multiple angles. So we're just going to do a bit of a loop to be able to do that. So first up, what we need to do is install matplotlib. So this is going to give us the ability to test out our model before we go and run it. So I'm just going to run !pip install matplotlib. And it looks like I've already got that installed, so we're good to go. Then what we'll do is we'll actually import it. So import from matplotlib, import pyplot as PLT. So that's going to import the core dependency, so pyplot, to allow us to actually render out our angles when we're testing out. So to do that, we've written from matplotlib import pyplot as PLT. Cool. Now we're all well and good. Now the next thing that we actually need to do is determine which joints that we actually want to render. So if we go back, or which angles we actually want to calculate. So if we roll on back over to here, so we can actually calculate the angle between any three joints. So in this case, you can see we could calculate 432, so this angle here. You can calculate 876, so that angle there. You could even calculate this, so 501. So you could calculate that angle there as well. Now, in this particular case, what we're going to do is calculate a few different angles. So let's actually scroll on down, and we're first up going to set up a variable, which is going to store which combination of joints we want to render. So let's go on ahead and do this. Okay, so first up, what we're going to do is we're only going to work with two angles, but then what we might do is we might add another one later on. So in this case, we're going to calculate angle 876, which is going to be 876, so this angle here, and then I think we'll pass through 12, 11, 10. So 12, 11, 10. So we're going to do that angle as well. So it's going to be the first finger, so this one, and then this one. So we'll calculate this angle here and this angle here. So ideally, when we put our fingers down sort of like this, you should be able to see the angle calculated just there. Again, that's probably really hard to see, but you sort of get the idea. This angle here. So let's go on ahead now. And again, similar to what we did for part 4, we're going to be writing a function that allows us to do this. So let's go on ahead and write up this function. So in order to do this, we're first up going to start by defining a function. So def draw underscore finger underscore angle. So this function is actually going to render directly to our image. So we're not going to need to go and do any additional rendering. It's actually going to do it all for us. Then to that, we've passed through 3 arguments. So image, comma, results, comma, joint list. So our image is going to be the image that we're working with from our webcam. The results is again going to be that big results array, which includes the multi-hand landmarks and the multi-handedness variables or results. And then we're going to pass through our joint list, which is going to be this. So let me just, I don't think we actually explained our joint list. So our joint list is just an array with sets of arrays inside of it. So again, if we wanted to grab our first joint value, so joint list 0, that's going to be 876, which is going to be that first finger. If we grab the second one, that's going to grab 12, 11, 10, which is going to be the second finger as well. So again, if you wanted to add multiple different joints or multiple sets of joints, you could just append to this joint list and we'll be able to get that. So that is the beginnings of our function now defined. Now what we're actually going to do is we're going to loop through each joint and then actually calculate it and render it to the image, so we'll actually be able to see the results in real time. So let's go on ahead and do this. Okay, so before we go any further, I wanted to sort of take a little break and show you what we've done so far. So what we're first up going to be doing is we're going to be looping through our different hands. So this is this line here. And then we're going to loop through the different joints, loop through, or joint sets. And then we're going to be extracting the different coordinates that we actually need. So this is going to be our second, and this is going to be our third. So to do that, we've written for hand in results dot multi underscore hand underscore landmarks and then colon. So that loops through our different hands, and then we're looping through our joints. So this should actually be joint. So for joint in joint underscore list. And then what we're actually doing is we're grabbing the 3 different coordinates that we're actually going to need. So this is going to give us coordinate first, second, third. So as long as your second coordinate is the coordinate for the angle that you want to calculate, then you should be all good. So in this case, 8, 7, 6 is going to be our combo, then 12, 11, 10 is going to be our combo, so on and so forth. So what we're doing is we're extracting each of those different coordinates. So A, B, and C. Now to do that, let me break that down. So first up, what we're doing is we're grabbing our X coordinate. And to do that, we've grabbed hand.landmark, and then we've grabbed joint 0. So if I show you what that looks like, so we're grabbing results.multi-hand landmarks. And we're grabbing our first value. Oh, and it doesn't look like we've got any results yet. So the reason that we don't have any results is because, remember, we took our hand outside of our frame. So let's run this, keep our hand in the frame, so we've got some results we can prototype with. Let's try that again. Cool. I'm going to hit Q. All right, so we should have some results to work with now. So results.multi-hand landmarks, so that gives us our landmarks. And then what we're doing is we're grabbing .landmark, or we're grabbing our first value, because remember, we need to loop through our hands first. So this effectively is hand. Right? Then what we're doing is we're grabbing hand.landmark. So that's going to give us all of our landmarks in an array. And then we're going to grab the coordinate for joint 1. So remember, we're looping through each of our joints. So in this case, let's just set our joint to 1. So joint equals joint list. So what we're doing is we're then going joint 0. And so that is going to give us all of our different coordinates for that first initial joint. Now again, we could change this to joint 2, which is effectively index 1. And now we're grabbing that next joint. So again, you can go through and loop. Effectively, what we're doing is we're going through and looping through these. Now, what we're effectively doing is we're grabbing the X coordinate, and then we're grabbing the Y coordinate, which gives us that. Now what we want to do is actually store it inside of an array. So we're going to use the NumPy array method. So if we do that, put it in square brackets, np.array, what we're going to get back is an array of coordinates. Now, again, this isn't refactored for the dimensions of our webcam, but again, it doesn't need to be for now because we're just calculating our angle. When we actually go and render it, we need to go and do that transformation. Then what we can do is we can go and apply our standard trigonometry to be able to go and calculate these angles. So first up, we're going to calculate the radian, convert that to an angle, and then provide the rendering script. So let's go ahead and finish this off. Okay, that is our code done. So let's take a look at what we've written here. So we've written 1, 2, 3, 4, 5, 6 lines of code. So again, what this code is doing is we're drawing our finger angles using our image plus our hand results from this particular joint list up here. So again, first up, what we're doing is we're looping through each hand in our results. Then we're looping through each set of joints in this joint list here. And to do that, we're grabbing our A value, our B value, and our C value. So A is going to be our first coordinate, B is going to be our second coordinate, and C is going to be our third coordinate. Now, really, all we're doing here is we're grabbing the hand.landmark out of this results value here, or results.multi-hand landmarks. Then we're grabbing joint 0, which is effectively, in this case, say we take a look at our first joint list or joint value in our joint list. It's going to be 8. Then we're going to do the same to grab B. It's going to be 7. And then we're going to do the same for C, in which case it's going to be the value 6. So that's going to give us our different coordinates for 8, 7, and 6. So this will be A, B, and C. Now, what we're doing with those 3 values is we're using our standard angle calculation formula. So first up, we're creating a variable called radians, and we're setting that equal to np.arctan2. We're passing through C1, which is effectively our y value for our C coordinate, then passing through our y value for our B coordinate, then we're passing through our x value for our C coordinate and our x value for our B coordinate. So this is just a little bit of trigonometry. So I got this from the baseline code for the angle calculation in Android from the official MediaPipe code, but I tweaked it to be able to work with Python. Then the next part to that line of code is minus arctan2, and then instead of passing through our C and our B coordinates, we're now passing through our A and our B coordinates. So A1, so this is effectively Y for our A coordinate, minus B1, which is Y for our B coordinate, comma, A0 minus B0, which is effectively X for our A coordinate and X for our B coordinate. And then we're passing our radians value to this next line. So angle equals np.abs, which is effectively going to convert this to an absolute value. Radians multiplied by our 180.0 divided by np.pi, which is our pi value. And then because we don't want our angle to be greater than 180 degrees, it's going to be a straight angle. We're just saying if angle equals greater than 180.0, convert it to its sub 180 equivalent. So angle equals 360 minus angle. And then we're going in ahead and rendering it to our image. So cv2.putText, and then we're passing through a bunch of values to that. So first up, we're passing through our image. We're then passing through our rounded angle. We're then converting our B coordinate, which is up here, to a value which has been refactored for the dimensions of our webcam. So again, really similar to what we did over here. So cv2.putText. So remember, we got our coordinate inside of our getLabel function, and then we actually use the cv2.putText method over here. Again, down here, we're using cv2.putText, but in this case, because we've already got our coordinate extracted for B, we're just running tuple, and then we're passing through np.multiply B coordinate multiplied by 640, 480, converting that to an integer. So at dot as type int. And then we're setting the other parameters that we need. So cv2.font_Hershey_simplex, passing through our font size, setting our font color, which in this case is going to be white again, and then passing through our line size and cv2.lineAA, so our line type. So let's just undo that. So that should be all well and good now. So if we run that, no errors. And if we just delete those 2 cells. So let's actually go on ahead and test this out now. Oh, and then the last line of code is we're actually returning our image that we've drawn on. So return image. Now, if we go on ahead and test this out, ideally we should get back an image which has our different angles calculated onto it. Now, this is the reason that we actually install Matplotlib, because we can type in plot.imshow image, and this is going to render our image which doesn't have our coordinates rendered on it at the moment. Now, in this case, it's rendering in a weird color, and that's because you need to recolor whenever you're working with OpenCV. So to do that, you can just type in cv2.cvtcolor, pass through your image, comma cv2.color bg to RGB. So this should look a little bit better now, and it does. So that's our proper true color. So again, this cv2.cvt color allows you to just recolor your images. So that's well and good, but remember, we haven't actually gone and updated our image yet with our angle calc. So if we go and pass through or run this draw finger angles function, we should be able to get our image with our different angles now calculated. Now again, it's probably going to be a little bit small, but that's fine. So let's do this. So test underscore image, so we'll create a new variable, equals draw finger angles, and then we're going to pass through our image, which is this down here, pass through our results, and pass through our joint list, which is this. So that looks all well and good. If we type in test image, you can see that we've got our image, looking good for now. And now if we change our plot.imShow method to, rather than rendering our baseline image, render our test image, you can see it's really, really small there, but we've actually got our angles calculated. It's 177.42 and 178.09. So we've actually got our angles calculated. So this is just a bit of a test run. Now, what I actually want to do, and if you want to get rid of this line here, you can just type in plot.show. So what we actually want to do is, rather than running this on a single image, we want to do this in real time. So what we'll do is we'll copy this code over again. So this is the code from step 4. And we'll paste it down here. And then we're just going to add in another line of code just below where we rendered our left or our right detection. So let's go on ahead and do that. Cool, so that is our last line of code written. So to do that, what we've gone and done is in line with our for loop over here, we've just gone and written draw underscore finger underscore angles, pass through our image, our results, and our joint list. So you can see it's only indented in line with this for loop here. So it's in line with that. So now what this should do is effectively render all the different angles from our coordinate list, which is our joint list up here. So ideally we should get the angles calculated for 876 and 12, 11, 10. So let's go on ahead and test this out now. So all things holding equal, this should run successfully. So we'll now have our left and our right hand detected, but we'll also get our joint coordinates. And you can see that that's doing it. So it's all in real time. So you can see we've got 178. And if I curl over, you can see it's changing that number there. Pretty cool, right? And it's going to be doing it for both hands. So this is, so you can sort of see that it's not always getting our left and our right hand. So I found that if you do that weird hand twirl, it actually resolves that. But again, you can start to see our different angles calculated there. So you can see that to the screen. So we've got that. And if we curl in, they're re-rendering. Pretty cool, right? There's a thumbnail if ever I saw one. Let me smile for it. All right, now what we want to do is, so right now we've got two sets of angles calculated. So this one, this one, this one, this one. Rather than just doing those two, let's go on ahead and add a new one so you can see how to actually go on ahead and do that. So if we quit out of this, so we've gone and done 876 and 12, 11, 10. Let's go on ahead and add another one. So what's the one that I saw that looks really good? It is 432. So 432 is going to be this coordinate here. So for our thumb, so it'll be that, right? So 432. So let's go on ahead and add that. And let's actually go and add another one, screw it. So let's do, I think that'll be good. So let's do 105. Where's our joint list again now? So all I'm doing is I'm now adding additional values to our joint list array. So I'm going to add 1, 0, and 5. So remember we first started out with just 876 and then 12, 11, 10. Now I'm adding 4, 3, 2 inside of an array, and then 1, 0, 5 to give us those new angles. So if I run this joint list again, so now if we take a look at our joint list, we've got 4 different sets of coordinates. And if we take a look at value 0, it's going to be 876. Value 1, it's going to be 12, 11, 10. Value 2, it's going to be 432. And value 3, it's going to be 105. Now, if we go and run this block of code again, because remember, we're now looping through our joint list inside of our draw finger angles method, we should get all of our new angles drawn. Now, if we actually test it out on our test image, let's actually do this. And we don't have an image rendered. Why is that? That should be fine. What's happened there? NumPy object is iterable. Oh, because remember, we would have taken our hands outside of the frame, so we won't actually have anything in results. Multi-hand landmarks. That's fine. Cool, let's just go and test it out in real time and see what it looks like. So let's go on ahead and run this. All right, so we've got the gray pop-up. If that happens, just run the cell again. Cool, so we've got our pop-up now. And look at all the angles. Oh, so the one on our wrist is obstructed by the left and right hand thing, but that's fine if we went and commented that out. You can now see that we're calculating all of those angles, right? So it's pretty cool. So it just automatically loops through and renders all of them. Sweet. And you can see, let's go and comment out the left and right thing so we can actually see that. So if we comment out this, actually we just need to comment out this line. So if we run that again, so if we just comment out the cv2.putText method under the render left or right detections, this should allow us to see that angle there. So let's go on ahead and run that again. And again, so we've got the gray pop-up. Boom, that's all of our angles calculated. And then you can see if we open up our hand, that's going to give us the angle near our wrist. How cool is that? So you've got all of your different angles calculated in real time. Again, post for the thumbnail. So you can see that you can mess around now. So you've got all of these different angles calculated. Pretty sweet, right? If we go and move our hand around, all of these are recalculating. Awesome. It's probably enough of me messing around, but you sort of get the idea. So you can do so much with this. In this case, we've gone and done our left and our right hand detection, and now we've gone and applied a custom angle calculation. Pretty cool, right? So let's take a quick recap and see what we've gone ahead and done. So we've now gone through step 4. So we've detected our left and our right hand landmarks. And again, sometimes it might be a little janky, but you can play around with it and swivel your hands around and it tends to work okay. There are different methods to do this, but I figured I'd show you the native one for MediaPipe. And then the second thing that we went and did is we calculated our multiple sets of angles. Now remember, you can go on ahead and update your joint list to be able to render different landmarks if you'd like to. So to do that, we went and created a new method called draw_finger_angles, and we applied it to a big block of code. But on that note, that about wraps it up. Thanks again for tuning in, guys. Hopefully you enjoyed this video. If you did, be sure to give it a thumbs up, hit subscribe, and tick that bell so you get notified of when I release future videos. And again, let me know how you went with this, and if you had any problems, by all means, hit me up in the comments below. Thanks again for tuning in. Peace.